Processes and cycles. Whenever one or more of the properties of a system change, we say that a change is in a state has occurred. Let me write when one or more of the properties of a system change. We say that a change in a state has occurred. A change in a state For example, when one of the weight of the piston in this picture is removed, the piston rises and a change in a state occurs. For the pressure decrease and the specific volume increase, for the pressure decreases and the specific volume increases. The path of the, so if we remove a weight on the piston, is removed, the piston rises and a change in a state occurs. For the pressure decrease and the specific volume increase. For the pressure decrease and the specific volume increase. The path of the succession of the states through which the system passes is the process. The path of succession of a state through which the system passes is called the process. Let us consider the equilibrium of a system as in the undergoes a change in state. The momentum the weight is removed. The moment the weight is removed from the piston in the picture above. Mechanical equilibrium does not exist. As a result, the piston is moved upward until mechanical equilibrium is restored. The question is this: since the properties describe the state of a system only when it is in equilibrium, how can we describe the state of system during a process if the actual process occurs only when equilibrium does not exist? One step is finding the answer to this question. Consider the definition of an ideal process. Which we call a quasi-equilibrium process. A quasi-equilibrium process is one in which the deviation from thermodynamics equilibrium is infinitesimal and all the states the system passes through during a quasi-equilibrium does not process is one in which the deviation from thermodynamics equilibrium is and all the states the system passes through during a quasi-equilibrium process must be considered equilibrium and all the states the system passes during all the process can be considered equilibrium condition. Many actual processes closely approach a quasi-equilibrium process and may be so treated with essentially no error. If the weight on the piston are small and are taken off one by one, the process could be considered quasi-equilibrium. However, if all the weight are removed at once, the piston will rise rapidly until it hits the stop. This would be a non-equilibrium process. So if, for example, all weight in the previous picture removed, the process is suddenly the piston suddenly the process is not equilibrium accurate. When piston suddenly hit the top. For non-equilibrium processes, we are limited to a description of the system before the process occurs and after the process is completed and equilibrium is restored. We are unable to specify each stage through which the system passes or the state at which the process occurs. However, as we will see later, we are able to describe certain overall effects that occur during the process. Several processes are described by the fact that one property remains constant. The prefix iso is used to describe such a process. The isothermal process, for example, several processes are described by the fact that one property remains constant. Processes are described by the fact that one property remains constant. The prefix iso is used to describe such a process. An isothermal process is a constant temperature process, and for example, an isothermal process is the process that temperature is constant. And for example, for pressure constant, we have isobar process. An isothermal process is, as we said, an isobar. Sometimes isobars process said that isentropic isopiastic process, isopiastic process, and isochoric process is constant volume, constant volume is we say that isochoric. Is a constant volume process. When a system is in a given initial state, goes through a number of different changes of the state of process and finally returns to its initial state, the system has undergoes a cycle. When a system in a given initial state goes through a number of different changes, state goes through a number of different changes. A number of different changes. Of a state or processes and finally returns to its initial states. Returns to its initial state. The system has undergoes a cycle. Undergone a cycle. Therefore, at the conclusion of a cycle, all the properties have the same value they had at the beginning. All in the cycle, all the properties have same values at the beginning in the end of cycle. Steam, for example, that circulates through a steam power plant undergoes a cycle. The distinction should be made between a thermodynamic cycle A distinction should be made between the thermodynamic cycle, which has just been described, and a mechanical cycle. A 4-stroke cycle internal combustion engine goes through a mechanical cycle once every 2 revolutions. However, the working fluid does not go through a thermodynamic cycle in the engine, since air and the fuel are burned and changed to products of combustion that are exhausted to the atmosphere. In this book, the term cycle will refer to thermodynamic cycle unless otherwise designated. The next section is unit for mass, length, and time and force.